Let me begin with a word of prayer. So here we go. Heavenly Father, we thank you for this day. We thank you for the beautiful weather outside and for Quiz 2 being done. We pray that we could learn from it and that everybody would just do better on the test. And we just thank you again, Lord, for your many, many blessings and for your creation and for being the good and awesome God that you are, Lord. In your name I pray. Amen. Okay, so any questions about the quiz before I start talking about problems? All right, so number one, so if you look at these graphs, right? Let me just kind of explain over on the other board how to think about the graphs, and then I'll, I think by and large, many of you got these right. All right, on the average of things, most people got a lot of things right here. There are a few exceptions, of course, but let's see here. So the one is y, let's see, part one is what? Y equals 3 minus, what is it, the square root of x plus 8? Yes. So what I would think about is I take the square root graph, right? And then I move it 8 over here. Then I flip it. And then I add up 3. So it should look something like that. Now, of course, there are other ways to create such a graph. But the generic feature here, the thing that I would have done as a student, is I would have looked at this and I would have went, well, a square root function is what? It's like half of a parabola turned sideways, right? And as I look at these shapes, there's really only one here that looks like half of a parabola turned sideways, right? It's not A, it's not C, it's not D. So, by process of what things look like, it has to be B, So I could have made the problem more nuanced, right? What if this problem was just 4 square root functions moved around in different ways, right? That could happen. That could be a different variation of this problem, right? So it is, in some sense, this question isn't too deep because I've given you 4 dissimilar types of functions, right? So even a surface level understanding here should allow you to distinguish between the choices, yeah? The next one, well, let me just talk about the 2. Y equals 2, absolute value of 2x plus 6. So I would think about starting with absolute value, then I make it go up like that, right? And let's see, maybe this is helpful. This is absolute value of 2 times x plus 3, right? So maybe I should, instead of doing this first, well, fine, I did that. So here's y equals absolute value of x. Here's y equals 2 absolute value of x, which is the absolute value of 2x. Then if I take that graph and I shift 3 to the left, that would be that, right? So, which is, of course, now you didn't have to show all these steps, right? But you could kind of think through these kinds of things in your mind, or some subset of them. And so it's not, anyway, the larger point here is absolute value is a V, right? Either upside down or right side up. It looks like a V moved around. That's an absolute value graph. And there's really only one of these here, which is this one, right? Oh, man. What the what? Oh, no. That is not right. What has happened here? Rats. Something got lost in translation, folks. So I think I see what happened here. This is none of the above, is it? It's a good thing I didn't gloss through these, right? So there's an error in this quiz. I just noticed it now. And holy cow. So I have 120 college algebra students. Not a single person called me on this. And, yeah, so you guys are just like, so just the surface level? Yeah. So this right here, if that's 0, and that's 10, 2, 4, 6, 8, 10. So this has got like a -4. And let's see here, that's at like 2, 3, 3. I'm trying to make sure it at least has slope 2. Does this have slope 2? It looks like it has slope 2. So I think it's just technically this should have been one of the choices, right? Excuse me, if this is one of the choices, then the graph should look more or less like this, right? But the graph that's given is like this, right? Roughly speaking. And so this is, I think that the correct formula for what I have pictured is actually, that's a -4. So I should have really had this as one of the options. So sorry about that, guys. But I don't think I actually confused anybody by it, because otherwise there would have been a comment somewhere. As far as I saw, there was no comment about this. If this is actually what confused you, you can let me know and we can talk about it, okay? But anyway, so next up, let me just kind of go on here because we should spend more time on the later problems where you guys have more problems. So the cube root, it's a cube root, right? So it's got to be this one, yeah? So the cube root is the one that looks like a cubic function turned sideways. And and number 4, well, that's a volcano graph. There's only one graph here with a vertical asymptote, and it's A, right? So A had to be that one. All right, enough then. Let's move on here. So sorry about that. I must, well, nobody. Man. Nobody. Interesting. Ah, my eraser shirt. It got dirty with a half a semester of erasing. It happens.
Gotta get a new one.
I just gotta wash it. Now, let me go down to the next problem here. So, and I will post a PDF of the solution here, probably the end of business today, okay?
Yeah. Sounds good.
I'm still waiting on a couple things, but yeah, even if I posted it, so even if I posted it right now, you wouldn't be able to get it anyway?
Of where we're right now.
Huh.
So it would be nice.
That's funny, because it seems like my computer just downloaded something, but whatever. Hey, if you guys say we can't do top hat, who am I to look a gift horse in the mouth? Let's see here. Okay, so number 2. So you guys are gonna have to help me out. When I stand here, I can't read it for whatever reason, and I've not.
Let y equals x squared minus 8x plus 11.
Thank you.
Find the coordinates of the vertex and x-intercept.
Okay, so yeah, we're supposed to find the coordinates of the x-intercepts and the vertex, right?
Yeah.
So how do you do that? So as we talked about, to understand the parabola, yeah. So to understand the parabola, we know the vertex form is this, right? So we want to put it into this form so we can see the vertex. So this, we complete the square. We've got x minus 4 squared minus 16 plus 11. And so you guys, some of you are being very careless with completing the square. I mean, I see that you've got the right idea, but you're still being very careless with the arithmetic. And unless you're careful with the arithmetic, this all falls apart, unfortunately. But wowzers. So there you go. I've completed the square and cleaned up the arithmetic. This already tells me the vertex is where? Yeah, 4 minus 5. Now, a lot of you have minus 4 there. You guys got to get that out of your system. Right? We're looking for x minus h squared. Right? There's no minus there. I didn't take off points universally for that error. It kind of depended on what else you did. Okay, now what? Now we can factor this because it's a difference of squares, right? Because if you take, use your imagination here, you can see that that's a square root of 5 squared, yeah? So I can factor, and I get x minus 4 plus the square root of 5, x minus 4 minus the square root of 5. And from that, I can read off x-intercepts. So this shows me that I have, this is 0 when x is equal to -4 plus or minus the square root of 5, right? So this tells me that the x-intercepts are -4 plus root 5, comma 0, and -4 minus the square root of 5, comma 0. Those are your x-intercepts. Did I do it? Okay, and so I've just made the error I was criticizing you guys about. So thank you. I'm very happy to have that correction. Haha, good. People are paying attention. Woohoo! So that's supposed to be a plus. And that's supposed to be a plus. And that's supposed to be a plus, right? Very good. There exists a possibility I made that error on purpose to see if you guys would catch me. It's one possible interpretation of what just happened. Just saying. Any questions about this problem? Yep.
Is there another way to find the vertex? Or is that just
Well, yeah, I mean, you could use the formulas I derived for the vertex and plug it in. But this is by far the easiest way.
I still don't understand how to complete the square. I think that's where I was wrong.
Well, you should work on that,
Yeah.
I suppose. Yeah. I mean, I'm happy to help. If you come to office hours, we can just do 10 of them if you want.
Sounds good.
Let's see here. This problem, yeah, we're good. But yeah, you're right. We did derive formulas in terms of A, B, and C for the vertex. And you could have done that. To find the x-intercepts, you could have used the quadratic formula if you did it carefully, right? There's lots of other things we could do here. If you're just a beast of algebra, you could have just straight factored it. I mean, right? If you really have insight into numbers, you could just be like, well, this factors is that, obviously, right? But that person does not walk among us. I'm not that person. Yeah.
Maybe my notes are just wrong here, but in my notes I have a parabola theorem and I have h equals negative
Uh-huh.
over 2a.
Oh yeah, yeah.
Does
Those.
that work too?
Yeah, those are the formulas.
Okay.
You could use
I
that.
guess I messed up my math there.
Yeah. Okay, so let's move on here. The next one, I said fill in the blanks. We're looking at y equals to
X squared minus 4 over x squared minus.
All right, so we're supposed to fill in the blanks for x-intercept, vertical asymptote, and hold the graph. Perfect. I'm mostly just checking on that. It's liable to my power cord is a little touchy. Okay, so factor this thing, right? We got ourselves an x plus 2, x minus 2 upstairs. And downstairs, we've got ourselves a x plus 1, x minus 2, right? So what are the critical numbers? We got a minus 2, a minus 1, and a 2, right? And each one of these is different. So some of you have more than one number in the first case or the second case. Nobody in the third case as far as I remember, but there's just one of each. So if you've got more than one, you're wrong. All right? There's another possibility, which is I thought you're writing a list, but you're actually writing some of you write, I say find the coordinates and you don't put you don't put parentheses around it. That's kind of weirding me out. Like for the last problem, it would be like if you said the vertex was minus 4, 5, that's the vertex. Well, it's really, really bothering me to leave it like that, right? Because that's not the vertex. Our notation is, this is the vertex, yeah? So if you're writing a point, make sure you put the parentheses around. Otherwise, I think you're writing a list of numbers, So, yeah. Anyway, let me get to the point here. Let's see here. So this is a hole in the graph. That's a hole because we've got both factors top and bottom. That's a hole in the graph. The -1 is going to give us a vertical asymptote. And the -2 is going to give us an x-intercept. Let me talk more about that, though, in terms of format. Now, I didn't take points off universally on this, but let's be fussy. The x-intercept is what? It's technically at -2, 0. That's the x-intercept, right? The vertical asymptote is actually x equals to -1. So vertical asymptote is given by an equation, you know? But hey, if you just said -1 is where the vertical asymptote is, I did not fuss. I might have written x equals -1 under that, because I want you to understand, like, that's the, you know, what we should say if we were going to be more picky. The hole in the graph, how do we figure that out? We need to look, it's the same on the top and the bottom, but we also need to look at the reduced function, right? So the reduced function is when we cancel the factors out, we get x plus 2 over x plus 1. And I must say, a lot of people had this. A lot of people, there were no shortage of people who got this right, and so I was happy about that. F reduced of 2 plus 2 over 2 plus 1, which is equal to 4/3. So finally, the hole in the graph is actually 2 comma 4/3. That's the hole. The hole in the graph is that. All right. So if I ask a question like this on the test, I'd like to see everybody get this one right, because we spent a lot of time on this, and like, you can get this. This isn't that bad, really, right?
Yeah.
So, what's that? You get confused. Yeah, well, you have lots of company. So, yeah.
How'd you know to put 2 in as the x and reduce?
Because we're canceling x minus 2 over x minus 2, so the hole in the graph is at 2, and the rule is that we plug in where the hole is into the reduced function to find out, like, where the hole is. So that's just part of my. This why is it 2? It's because we're canceling the x minus 2 over x minus 2 is the simple answer. Does that make sense? So in contrast over here, that is 0 when we plug in x equals to -2, which is why there's an x-intercept at -2, 0, because the function is 0 there, because we got like 0 over stuff, which is just 0. In contrast, 0 over 0 is undefined at 2, which is why there's a hole in the graph. All right, let me move on here, yeah? Let's see here. So this one, there exist people here who got it right, and there exist people here who got it wrong, and kind of everything else in between. You got it right it was a miracle?
Yeah. I did some sort of math.
You did some kind of sort of math?
Yeah.
All right, so so here's how we do it. So 3f of 2 is equal to 3 times, what is f of 2?
2.
So we can look. Oh, you're okay. I need to tan up a bit here. I guess I'll just zoom out. Well, no one's going to see it, but oh well. So if you look at this, where did I put my phone? Did I not bring my phone? Oh well. I'll know when class is over. You guys will start packing your bags, right? Let's see here. So f of 2, this is the graph of f, right? So I go to 2. I go up here. F of 2 is actually equal to 2. So I have 3 times 2, which gives me 6. All right? That's all there is to that. Fg of 1, by definition, is f of 1 times g of 1. This is the product of two functions. All right? I go over here. F of 1 is what? Oh, minus 1. I can't do my own. You guys got to stop me. Minus 1. Thank you. I lost track of the minus 1 and minus 1 here, right? F of minus 1 is what? It's 0, right? Right here. F of minus 1 is 0. So does it even matter what g of 1 is? Not really, right? But it does so happen that g of 1 is also what? You got to plug 1 into the formula for g, right? G of x was what?
3x squared minus 3.
Okay, so if we plug in minus 1 into that, we get 3 times minus 1 squared minus 3, which is also 0. So anyway, you slice it. So if you understood either part of that, you would get it right, right? It's hard to get this one wrong if you've got part of it right, you know? Now the last one, f composed with g. That little circle means something, so that's the composition of f and g. We'll be talking a lot more about that after test 1, okay? Because we're going to cover inverse functions next here. But f composed with g of 1, this by definition is f of g of 1. What is g of 1? That's f of, yeah, g of 1 is 0 because that's 3 times 1 squared minus 3, which is f of 0, which is what? What is f of 0? Well, I got to go back to my graph again. F of 0 is 1. So that's all there is to that one. All right?
I was overcomplicating.
You overcomplicating things? Yeah.
I was like, okay, it has to be this, this, and this.
I hear you.
This is way
These things will happen. Let's see here.
So the answer is 6 or is it 1?
The answer is 6, 0, and then 1.
It's not really anything I was using, so I thought I was trying to find out.
All right, so the next one here. Actually, what time is it, guys? 12:33. Can we skip 5? Would that be okay? I'm going to post the solution for you to look at. Would that be okay if I skip 5?
Yeah.
All right. If we have time at the end, we'll come back to it, okay? Problem 6. All right, so yeah, problem 6. Here we have f of x equal to, what was it, x cubed minus 6x squared plus 11x minus 6. All right, and I gave you a hint. I said evaluate f of 1 and f of 2 to completely factor and then completely factor the function. So, all right. And so let's look at that. What is f of 1? F of 1 is 1 minus 6 plus 11 minus 6. F of 2 is 8 minus 24 plus 22 minus 6. Getting to the point, those are both 0. Those are both 0. That means, what does that mean? Well, that means that some of you whoa. There's that, yeah. So that means that x minus 1 is a factor. Factors f of x, right? And it says that x minus 2 factors f of x. And you can put these together, and you can get that x minus 1 times x minus 2, which, by the way, is x squared minus 3x plus 2 is a factor of f of x. And then we can divide that in there. And if we do that, we get 9, let's see here, 9x squared plus 9x minus 6. So I think that's going to give us a minus 3 up here. I did something wrong there. Oh yeah, is that 9x squared? What's 6 minus a minus, excuse me, what is minus 6 minus a minus 3? It's minus 6 plus 3, right? Which is what? Not 9, negative 3. Thank you. So I should actually do, did I?
Well, that's 6 minus 3. 9, because they're both negative.
There is a.
That's perfect. You got it right.
Oh, okay. Okay, good. I'm sorry, just something bothered me. My bad. Okay, so that gives us minus 3x squared plus 9x. Oh, yeah, I'm sorry, minus 6. I'm looking for something that's not there. So the remainder is 0. And that tells us finally f of x is equal to x minus 1 times x minus 2 times x minus 3. Because this right here are these two, all right? And this goes there. So to reiterate, what goes on here, if we should see that f of 1 is a factor, f of 1 equals 0, it means x minus 1 is a factor. If f of 2 is equal to 0, x minus 2 is a factor. And whenever you have two factors and you want to divide both of them into something, the easy thing to do is to multiply them and then to use long division like I just did. All right? Now some of you like the synthetic division, so you could do 2 synthetic divisions to find the same, right? Or you could do 1 synthetic division and just factor, because what you get after 1 synthetic division will be like a linear factor and then a quadratic, and you can factor quadratics because the quadratic that you're going to get is either going to have, you know, 2 and 3 or 1 and 3 as zeros. Those you can factor. So there are other ways to do this, but this is the way I do it. All right, let's talk about problem 7. Many more of you are lost there. So here I give you that f of 1 plus 2i equal to 0, and I tell you that f of 5 is equal to 0. And I tell you that the degree of f of x is equal to 3. I tell you it's a cubic, right? And I give you other information. I tell you that f of 0 is 50, all right? So then the question is to find the polynomial with this data, right? And so let's just break it down. The complex zeros theorem tells me that x minus 1 squared plus 4 is a factor. When I multiply this out, I get x squared minus 2x plus 1 plus 4, which is x squared minus 2x plus 5. So this is one of my factors in the quadratic, in the cubic. And this tells me that x minus 5 is factor. All right. So since we have degree 3, we're done. So f of x is just equal to a times x minus 5 times x squared minus 2x plus 5. Annoyingly, I have asked you to find the standard form, right? So we're not done yet, right? Now we need to we haven't used this yet, right? So 50 is equal to a times minus 5 times 5, plugging in 0, right? Yep.
How do we get degree 3?
Cubic. Cubic means that. So that's a times minus, so that's minus 25a. So a is equal to 50 over minus 25. Did I do something wrong? Oh, no. I'm sorry. I was looking at problem 8. I was thinking this. It's fine. This is fine. Minus 2 is what you get. So we've got f of x is minus 2 times x minus 5 times x squared minus 2x plus 5. Now, I do apologize. I didn't give enough space for this particular problem. This needs like another inch, at least, in terms of white space. So poor planning on my part. Sorry about that. But now we just have to multiply it out to find the standard form, right? Standard form is when you have just a sum of powers with numbers. So to multiply this out, I'll leave the 2 out front. I got myself x cubed minus 2x squared plus 5x minus 5x squared plus 10x minus 25. Collecting like terms, I've got x cubed minus 7x squared plus 15x minus 25. Multiplying through the 2, I've got minus 2x cubed plus 14x squared minus 30x minus plus 50. If I haven't made an error, but I think that's it. Let me check. Minus 2x squared. Yeah, so there's the cubic and standard form that we want. And again, my apologies, I really didn't give enough space on this problem. Whenever that happens, feel free to work above the problem or say on the back of the page or whatever. I do try to print single-sided so you have a, Yep. How did I get to x minus 1 squared plus 4? This is the complex zeros theorem that we spent Friday talking about. So this is the complex zeros theorem. So anytime we have a complex root, we get a corresponding prime factor. So remember, if we had f of alpha plus I beta be 0, I told you guys that's equivalent to having x minus alpha squared plus beta squared as a factor of f of x. So in this problem, I have alpha equals to 1. I've got beta equals to 2, which gives me x minus 1 squared plus 2 squared, which is 4. Some of you have accepted the truth of this theorem and are using it. Others of you are ignoring it. So, if you ignore it, it's really hard to do these problems. Let's see here. Yeah.
What would be a real-life situation where you would need to know that theorem?
Oh, for example, if you have a spring
Yeah.
with under gravity without much friction, you can get an equation of motion which involves that. For example, like it gives you sines and cosines that are shifted a little bit. Oh, where in life will you need it? That's easier. That's actually an easier question. Next Wednesday,
Next Wednesday.
between noon and 1, for sure. Ah, well, that is not as clear cut because I do allow you guys a formula sheet, right? So I wouldn't say you have to memorize it, but you do need to understand it, recognize that you need to use it, right?
Yeah.
At least that.
Yeah.
Problem 8. A lot of you guys have almost everybody here has something right in this problem. And some of you have it exactly right, but some of you just like to bounce so much that you just got bounces on everything. But we only need a bounce at the middle one, and we want least degree, so we don't want cubes or anything on the outside ones. This will do. And then f of 0 is minus 48, which is a times 6 times 4 times minus 4, which is,
Oh, I did write it. Was that problem 7 that we just did?
problem 7 was the one we just did.
Oh.
That was problem 7. This is problem 7 over here. This is problem 7. The one I'm looking at right now over here is problem 8.
Oh, okay.
Yeah. And so I have a is equal to minus 48 over, 6 times 4 times minus 4. And that works out to minus 1 over 2. So the answer is just minus 1/2 times x plus 6 times x plus 2 squared times x minus 4. Now, some of you, as I had feared, are multiplying it out. But you notice that, so like some of you, I have students who have not multiplied it out on problem 7, where it does say standard form. I put it in bold. I tried to make it, I bolded it. See, I bolded the standard form. Right? When you look at your quiz, see the bold standard form. In problem 8, though, there's no standard form. You do not have to multiply that out. That's the answer. Yeah. What have I done?
Isn't it positive 1/2?
Oh yeah, positive. I'm sorry, because I got minus and minus, so it is a plus 1/2. Thank you. Thank you, thank you. I get carried away here.
Okay.
All right, and then finally the last problem here. What time is it? 47. I gotta bring my, not bringing my phone is just, I always feel like I've got 3 seconds left.
You can Apple Watch.
I should get an Apple Watch.
Or just a regular watch.
Just a I used to have a watch. I have had watches.
Get a Garmin. They're pretty nice.
Get a Garmin.
Yeah. I got a Garmin.
All right, guys. So this one, long division, 3x to the 5th plus 11x cubed plus 2x squared minus 10. All right. And over here we've got x cubed plus 2. All right.
That's plus 2.
And we're trying to decide, is x cubed plus 2 a factor of that 5th order polynomial? So if you want to do that, we just do long division and interpret the results. So this gives me 3x squared. So I multiply that out, I get 3x to the 5th plus 6x squared. Subtract those, like so. I get 11x cubed minus 4x squared minus 10. To get an 11 from this, I just do plus 11. And that gives me 11x cubed plus 22. Subtract those, we get minus 4x squared. Have I made a mistake? Nope, nope. Minus 4x squared minus 32. I'm always thinking of another problem. And at this point, we're done. When the degree of the thing you're subtracting, when the last remainder here has degree smaller than your divisor, here is degree 3, this is degree 2, that means you're done. And what this means is that 3x to the 5th plus 11x cubed plus 2x squared minus 10, right, divided by x cubed plus 2, what's it equal to? It's equal to 3x squared plus 11 minus 4x squared plus 32, all divided by x cubed plus 2, right? And no, it does not factor. It's not x cubed plus 2, not a factor. So if you did not answer, I said answer the question. So I asked you, answer the question, calculate the division, answer the question. If I need a yes or a no there, the question was, does it have a factor of x cubed plus 2? The answer is no, it does not. This shows that. And of course you can multiply it to see it, but anyway, yeah. If it had been a factor, we got a remainder 0, right? But we didn't, so it's not. Anyway, as I said, I will post the complete PDF that has the solution to problem 5. But I know myself. It takes us 15 minutes to work that problem 5 here in class. So now Monday, what should we do Monday?